So Gustav apparently had an issue with scheduling. It was a half hour that he didn't know what to do with. So he asked me, can you do something? And sure, I'll show something. So I'm going to show a little bit on some stuff we've been doing lately, but the name is pretty cool. You see it? Cutting Edge PGC. So yet another PGC talk. It's a lot of that. So I started thinking a little bit, so what should I do? I mean, I can just show some of the stuff first, but then I started thinking, what have I actually done? And how should I present it? So I wrote down a few notes. I don't know if I'm going to follow too much of it, but it is another PGC talk. So what is PGC? At this point, everybody knows what it is, right? It's everything and nothing. The title "Cutting Edge PGC" is pretty bold too, since if you look at it from a quality perspective, it would just mean better quality, right? Or if it's any of the other point that you're on this stuff, we can pick either one. But we're going to stick to some parts that I really enjoy, which is solving the problem for the user, trying to disregard everything else like parts and all that stuff. It's none of that. So if we look at the basics of PGC, we often talk about it. It's a feel, right? That's an important part of it. Feel and flow is very good things. So our basics that we always work on is, of course, our animations, and been talked about a little bit lately. What are the animations we write, and how do we do them, and how do we make it useful? So the basics is, of course, placements, the fact that they stretch things. All these things are by now common for anyone using this tool. In fact, if you have anything that has connectors, you grab those and it doesn't change, it'd be very odd, right? So stretching is a pretty big thing. But then when you start thinking about that, what is that? I wrote down here, this is completely just off my head, I was sitting in a bar. Good insert animation versus changes on a drawing. What's the value chain here, and what is difficult for us, and how is it difficult, and why is it difficult? And I basically just wrote down inserts, easy, change, hard. So it's a stretch animation always starts out so easy, right? I stretch this, 2 lines of code, width equals, yes, got it, perfect. Then you connect it to something else, and connection is just linear, it's still easy. Then you take a ton of panels, you place those and you interconnect everything, you throw some work surfaces in there. Suddenly it just absolutely falls apart and it becomes more and more difficult, right? Anyone experience this? Yes. So, well, we still want to do it, right? We strive to reach this. So that was the end of my first note, was basically we need to strive to perfect all these simpler things first before we can really look at the future. But the future is still coming, and I think Jörn often missed one point in the PGC. It's a feeling I have that more and more people think that what we have is that we're kind of done. It's like people have minor changes here and there, but where's the conceptual changes? Where will that come from? And quite often, I think the extension teams has to be driving this quite heavily. But in my little back office, I'll try to. So that's where we're going to end up with this. So then I looked a little bit, or I thought a little bit about what happened over the last few years. What has changed since I more or less left office 10 years or so? And there's been changes. I started reflecting on what I do now and what I did before and how all this happens. Over the years, there's all these, as you branch off in other industries, suddenly you need child snappers. So a lot of these little concepts start peeking up everywhere. And I started thinking about it. It really comes down to some sort of how we structure our data that is the snappers and everything else. So say if you do it in a static way, meaning you pick a structure. This is it. Abstract walls. Anyone work with that? Good example of an unholy system. Like, it's cool, but it's a very complicated structure. It probably made perfect sense to make it that way. But then we want to do something else with it, something that the designer didn't think of. Now all your code reflects the complexity of the structure that you built. And it becomes kind of an issue over time, I feel. We have more and more of these. So can you think of some areas where we have these little structures? Probably everywhere. Yes. So, of course, we can't not structure this. I mean, it doesn't work that way. But there's a couple of different ways to do this. So I started really, over the last few days, reflecting over the difference between more or less static data structures and more dynamic. Dynamic meaning that I create a structure from whatever data I have, depending on what I want to do. Not because the designer at some point thought it was cool to build very advanced trees. Right? So I jotted down, and this is the end of my speech, more or less. We're going to play a little bit more. N++ engine show. That's the rest of my presentation. So what are these things? So the N's are very powerful tools where a lot of times we talked about it. It came up a little bit yesterday, I think, on that you should start caching things. So where do you cache things? All these ideas. So it's quite common to think of it as you do some pre-calculations of things that could happen, and then in your stretch animation you can just toggle between these states without having to do so much calculation in the actual mouse move, right? So that's a simple version of an env, if you will. Now, using the word env is a little dangerous because a lot of people look at it as just basically taking a complicated args list, making it into one object and pass it around, right? That's a common use of an env. So then I coined the term N++. It doesn't exist, but I just need something for today to talk about. And it would be a collection of data that also comes with a couple of functions. So we're going to look at one of those little examples. The engine is a slightly different way of looking at this. And I'll hopefully swing back to that one in a second. So what I'm going to show now is, apparently now, it won't look so CET-ish. It's a little toy thing. Apparently we have to start it too. So while we wait for that. One thing I noticed in here, for the love of everything, stop cleaning. Not a single person here just restarts the software. Everybody hits clean. Exit, start. There's so much time spent on cleaning every single time you want to restart. That's just a reflection. Sorry. Hopefully, well, that was an itty-bitty little one. There we go. So it will look a little different. So we won't speak too much of that. But basically, this is a little toy thing, thinking of end user interface in a little different way. But we have the normal walls. Okay, so we want to play with these walls, and I didn't actually write this. I actually didn't know how this worked, so I just took a look at it 2 days ago because I figured maybe it'll fit this little talk, and it does. So I grab this wall and I pull it, and it acts more as a shape than a regular wall, right? Now when you look at this, you start thinking about it. So the concept of we should rewrite walls has been around since the day after I hard hacked them back in 2005 because they really need to be rewritten. But it's not that simple, it turns out. But one of the ideas I've always had is, oh, maybe I should just make shapes instead of individual walls, which goes against everything I speak of now. So that idea has died in the last 2 days or so. So how do you accomplish something like this? What I'm going to talk about now is, I think a lot of you do this already. I just want to reiterate it and give it some words that we can speak of maybe in the future. So we'll look at this wall. These wall lines are actually more or less the normal wall lines, as you can see. Still the ugly disappearing corners, all the niceties of our wall system. So there's really no main difference to them. They come from a slightly different class structure, but in the back of it is the same. So we'll hop over here, and since I just looked through this, I'm just going to quickly run down here, and somewhere we're going to have a big M. There we go. So you see the code, everyone? Can you size it a little more? All right, let's go. Assisted mode. Oh, look, I cleaned just because I said that.
I had 26 points yesterday. Maybe you can go on 22 on your screen or something like this.
I'll try. For the next presenters, if you're going to show Emacs, go back here and do it instead of every buffer. It's very annoying. So maybe this will work. Let's see. Good? Oh, empty out old crap. That's good.
Brave new world.
Brave new world. Yeah, I'm always nervous when my code is on the screen. I'm not a very clean person. So we'll hop back down here while it starts. So also I thought. I can't see my entire screen. There we go. All right. While we wait. Anyway, this will be. We speak of this, what we look at now would be an env++, meaning that at some point early on in whatever operation you want to do, you collect your data, you do a little, you analyze. In this case, it looks at the walls around, whether it should stretch them or move them. Just sets up a little data structure that's needed to perform this exact operation. And then in the stretch, hopefully, there we go. So, room stretch and. If you want to look at it, we can look at it. I don't think it's all that important, but since we're here, we have apparently a few minutes left to kill. Seems fairly straightforward. It's just a small data structure needed for this. I don't actually know how this works. I thought Andreas was here. I know he was in it pretty recently, toying with it. But we'll hop back. You create your little whatever it is, and at some point, you just run a function on it. So that'll be the difference between the env and the env++. Has anyone seen any of these constructions before? Have you written them yourself? Yeah? Once? One area where I wrote exactly this, I've written these throughout my entire life at Configure. I just never really thought about it. Early on for SteelCase, I toyed with the idea of just filling worktops or work surfaces around the 4-pack. So I just quickly wrote a little n. Panel stretch, if you ever looked at that, does exactly this. It starts a panel frame sequence, I think, right? Which is exactly this again. So let's move on, because now we're apparently running out of time. So this is a little kitchen toy thingy. Kitchens are interesting in the sense that everything is connected and you have constraints due to walls, and we don't move walls very often. So it often becomes just a renegotiation. I need to go from point A to point B. I have set corners. I need to just solve the permutations of things I can place there, right? So I wrote an early version. Just I wonder if I could do this. Permutations are cool. Let's hack something back in 2014, I think, just for the heck of it. And this is the previous version of what I'm working on right now. So bear with me a little bit. I'm not super comfortable with this code anymore because I haven't seen it in a little bit. But we're going to place a wall and we're going to place a door. And I don't know. We're going to build a kitchen. That looks like a good spot. Perfect. So when we speak of performance,
Good job.
but only first time. Second time is fine. Some annoyment. So, but what is it doing, and how did I come to this conclusion? Why did I make the decisions I did to create this? I created something that I call I don't even know if that's its name, DK engine, I think it's called. So it's an engine, and the engine is slightly different than the env in the sense that I actually it doesn't know about kitchen cabinets. It doesn't know anything. It just looks at the abstract idea of it, which is kind of neat. I disjoined myself from the actual products that are in here to create this. Then there's of course some lookups to see what you could build. You can't just randomize everything and hope for the best. But we can look at the engine if you want to. I would have to dig a little bit. But it's a cool little tool. I mean, already here, I think we could be done. This was super neat. What can we do? Skip that one. It keeps recalculating, it keeps building all these things for you. So we'll hop back here a little bit. So the upside of using, of course, a data structure like abstract industry or abstract walls is that you have a set data structure that you learn what it looks like, and you can always go in the code and look at it, and it's perfect. With my proposed way of doing this, you don't really have that. And I propose actually writing several different engines depending on the operations being done, potentially. So then it's a little bit more chaotic. So for my own sanity, which I don't have much of, but what little I have, I started writing little, like little graphical feedback. So this is what the engine sees of the kitchen. So now it's actually almost pretty. No, it's not. It's horrible. Pink means some sort of appliance. That's it. As you can see, it actually automatically inserted covers. So automatically building a kitchen is pretty much every other operation you will do in a kitchen. At any given point, you change the materials. Now you need to insert covers. In a room where you're stuck, you can't move anything, and you have a very discrete set of sizes of cabinets. Inserting one cover side could mean that you have to redraw quite a bit, because moving it over, now those 16 millimeters have to come from somewhere, and somewhere doesn't exist. So now you have to make some cabinet smaller, and then that means that there will be a filler piece, and it just keeps growing on you. Another common issue in the kitchens would be, and if you, I talked to a kitchen designer, and they say, it's a pain to draw U-kitchens. Of course, because you accelerate all these problems. If I have a corner, I set it, I built everything in between. Someone decides, I don't like that corner cabinet, I want this one instead. Now you're back to rewriting all of it. So in this case, I'm going to circle back to the value change of fast inserts versus changing the drawing as is. For kitchen, insert is not high value. It's what I've come to accept. I didn't really think this way before, but I do more and more now. So you need to be able to do high level changes to a drawing that you've done, or you want to do a number of different starting points. So it's a little unstructured now because I have so many thoughts on this, and none of them are actually finalized, so it's very hard to write down. Each time I write it down, it changes a little bit on me. So it's very annoying. But basically I set out to, what I'm attempting to do is a 3-level approach to how you specify a kitchen. I call them auto, assist, and detail. Detail is what we normally do. Piece by piece, you put it together by taking one product, next product, next product. Auto is this attempt at auto-generating a good starting point. It might never actually make the kitchen, or even I actually create useful kitchens already, but it might not create the kitchen. So it won't necessarily be that I say, give me a kitchen, all right, here's my money. Like, most people don't work that way. So I don't think that's the goal for this at all. So then we get back to the assist, and the assist is the tricky part. Unfortunately, I can't show too much on that, but it actually will use all the same things that I do in here. Basically, you make a change to something, these needs to be pulled, I need to pull all these things around, I need to borrow space from something. But if you write these in an engine, you can start reusing them. So we can just look at the engine, I guess, a little bit, really quickly. I'm almost out of time. Where is it? Ooh, question mark. Can I get there in a good way? Yes. So this is the old engine. Take that down. So it's based off, I don't really need to talk about this too much because it's all changed already, but it is based off some sort of apply elements, which means walls or runs or areas that I'm going to produce things. I have runs, and each run contains, I have to look, a number of items. Each item is one or multiple cabinets or something else. It's actually completely undefined. It doesn't even know about the kitchen racks, which are the classes for the snappers for kitchens. I'm trying to keep that very separated, because otherwise you end up hacking instantly. Like there's always, oh, what if it's a cover side? I'm gonna hack around this. I'm gonna hack around this. And you keep hacking around it all the time. So the structure doesn't really contain much. So it's curious that we're building kitchens, and I keep saying that I don't have anything. So where is anything happening? I'm gonna pop back to the engine. Set pop back there. So in this older version, it was called modules. Nowadays, I think they're called functions. But you can basically register all these running functions on it dynamically. So it will solve another issue when you create anything like this that's a little bit more abstract. It just dies. It dies of subclassing, and it doesn't take long. How many love all the abstracts we have? Yeah, neither do I. There's a lot of shame and a lot of decisions I made. Not because they were bad at the time, but they become bad over time. So this is a little bit of a way of trying to not have that happen, because the engine doesn't actually have much functionality. In my next version, there is literally nothing. I think there's 3 fields in the engine, and that's it. There's nothing else. But so we're going to run through this real quick. So here's a number of little functions that I put on it. So I create these little modules, so I throw them in there, and I can run them. And at any given time, you want to run this, and you want to handle fillers a little different, because for some reason you sell other stuff and you're going to run differently. You just replace the function, remove fillers, or whatever we have in here. I don't remember. Auto covers. What if you don't sell covers? We're not going to need this. Or someone might actually sell cabinets that has a real good material side instead, so that you don't need covers. But you might want covers anyway. But so you replace all these little things rather than trying to dig through these vastly complicated algorithms to figure out where are these covers inserted. Because it always goes really well until that point where it doesn't, and from that point it gets shittier every single day, and it's horrible. So this is my feeble attempt to try to break that cycle a little bit, and maybe I won't be so shameful of this when I'm done. It also has 2 more things that is kind of important. Yeah, this one's very messy. But the engine is based off import, export, and functions. That's all it is. So I import from something. In this current version, we build a completely different set of data. That is the population data. It says I'm going to build from 0 to 4 meters. We're going to build cabinets. Oh, am I out? All right, super quickly. So in this case, we import into the engine, build up items from the populate data. We run all our operations, and then we export it back out, which will create the actual kitchen cabinets, depending on whatever you sell. But this also means that I can import what I just exported and run the same functions again. So this is the neat part of it. The engine doesn't really care where the data comes from. It's just a structure you build. So all you have to do is build these importers and exporters. So you start looking at it, you take kitchens from one manufacturer, you import it, and then you swap out what it knows and you export. You will literally replace it. If they don't sell the same size cabinets, the engine will actually do everything for you, because that's the only thing it does. It's not something I have to create at this point. It already does this for me. This should have probably have been longer than half an hour. I'm not even scratching the surface. I'll come back on this one when I feel like I have my next generation working, because it's crazy when you start going in here. There's quite a bit of startup time writing engines. But when you start getting there, it just becomes easier and easier, and instead you just get high on ideas. It's like, I need to do all these things because it can do anything for me. So yeah, I don't know, was that PGC cutting edge?
Yeah, but of the things we've been talking about, strikes me, the first one is if you start to build these super complex tight data structures that you typically get pulled into with object orientation in classes and strongly typed language that we have. That creates a lot of complexity, and then you build even more. You add these M-based algorithms which just have a temporary state and supposed to run over all this data structure. They are totally dependent, right? So, and then when the problem set grows, the data structure grows, and all the dependencies grow, so it very much becomes almost like a quadratic complexity in coding.
Actually, thank you for saying that. That was actually on my note. I just completely forgot it. So the whole point of this was you shouldn't build structures at all. Keep it simple, little snappers. Create your structure here when it can reflect this actual problem you're trying to solve. So if the problem is different, you create another structure. You're no longer stuck in this massive swamp of complicated snappers. That is the message, I think. Oh yeah, that's the message. Go for that. But we're out of time, so there we go.
And then with the approach that he's done here is that he disconnects his algorithm completely from knowledge about fundamental types and just talks about properties that they have x-axis. So that's the import and export phase, right? And then you're modular, you have modularized yourself off, so you cannot even depend anymore. And you're forced to think differently, and that gives you a completely different route. So yeah, this is high-level programming to reach extreme PGC anyway. So
it's just a mindset, I think.
That's right.
It's as soon as you start, it becomes normal. It's like any other programming technique. As soon as you normalize it, you just do it, and it's not complicated.